This video is for lesson 22-4 about solving right triangles. Learning goals are to figure out angle measures by using trigonometry and to solve right triangles. And we'll talk about what that word means, solve right triangles. In the last lesson, we used trigonometry to figure out an unknown side length when we knew an angle in degrees. In this lesson, let's do the reverse. Let's use trigonometry to figure out the measure of the angle. So question 1, in right triangle ABC with acute angle A, you know that sine of A is the fraction the square root of 3 over 2. Draw a possible right triangle ABC. So let's draw a right triangle in the spot. Here's the 90-degree angle. We're told that one of the acute angles is called A. I'm going to choose to put that here. And then I'm going to put the letter B here and put the letter C here. Now, how can we label these sides? We're given that the sine of A is the square root of 3 over 2. Let's use our definition of sine, which I hope that you have on your notes by now. Sine is opposite over hypotenuse. So opposite from A, across the triangle, we can label the square root of 3. That's how long this side is. The hypotenuse we can label 2. So the long diagonal side that's across from the 90-degree angle box, we can write 2. Here's what that triangle might look like. What angle is this in degrees? We can find this using trigonometry. We're going to take that equation that they gave to us, that the sine of angle A was equal to the fraction, the square root of 3 over 2, and we're going to do an operation that will cancel away sine and leave us with the angle. That operation is called inverse sine. The symbol for inverse sine is the word sine with a -1 in the upper corner. It kind of looks like an exponent, but in this context, this means inverse. So we're going to take the inverse sine of that fraction that they give to us. When we do this, we will get the measure of angle A in degrees. This is something you do on your calculator. We have a button, sine inverse. It's the same actual button as the sine button, but you use the second key to make it work. When you type this in, the calculator will say 60. Then you're going to have to know to write a degree symbol in the corner, because what we're figuring out is the measure of the angle. We can figure out that this angle is 60 degrees. To figure out the measure of angles in degrees, we use what are called inverse trig functions. There are 3 of them. There is a function that is the inverse of sine. The symbols look like this. There's a function that is the inverse of cosine. The symbol looks like this. And the inverse of tangent has this symbol. Again, these are actual buttons on the calculator. We use inverse trig functions to figure out the measures of an angle in degrees. Let's try a bunch of these in question 2. Question 2a, what is the inverse sine of 1/2? You're going to use your calculator to do this. You have to push the second key so that when you push the sine key, it actually does sine inverse. And then in parentheses, type 1 divided by 2, close up the parentheses, and then push enter. See what the calculator says. Calculator says 30. Now the calculator won't put a degree symbol on the screen, so you'll have to know yourself to write the degree symbol in the corner, because when you find an inverse trig function, you're always finding an angle, and it's going to be measured in degrees. Now I'm going to pause the video for you to answer the next 5 of these questions. Going to 1 decimal place, here are the answers. Question B turned out to be exactly 60 degrees. Question C rounded to 26.5 degrees. Question D rounded to 48.6 degrees. Question E is about 41.4 degrees. And question F is about 36.8 degrees. Now there's different ways to round that last digit off. So if you said 36.9 or you said 36.7, that's close enough to get credit on a test in this class. Now that we know how to use trigonometry to find angle measurements in a triangle, we can learn a skill called solving a right triangle. Solving a right triangle means to figure out how long every side is and figure out the measure of every angle. Let's go to the next page and try this skill. Here on the side of the screen, we have a right triangle drawn. Side QS is known as 33 millimeters. Side SR is known, it's 65 millimeters. Angle S is known, it's a 90-degree angle. If we want to solve this triangle, we have to figure out all of the unknown parts of the triangle. So let's first list what we're trying to figure out. We don't know how long QR is. We're going to have to find that segment. We don't know the measure of angle Q. We're going to have to find that measure in degrees. And we don't know the measure of angle R. We need to find that measure in degrees. If we're able to find those three things, then we will know all 6 parts of the triangle. We'll know all 3 sides and all 3 angles. We can find these answers using a combination of trigonometry, the Pythagorean theorem, and our special right triangles. To figure out QR, which is the hypotenuse of the triangle, we can use the Pythagorean theorem because we know the other 2 sides. The shortest leg is A, the next leg is B, the hypotenuse is C when you use the Pythagorean theorem. Let's do that work just over here on the right. So A squared plus B squared equals C squared. 33 squared plus 65 squared equals C squared. Let's take a calculator and figure out the left side of that equation. This adds up to 5,314, and that's equal to C squared. Therefore, C is the square root of that number, and that equals 72.9. So we figured out that QR is 72.9. There's only 2 things left to figure out to solve the triangle, and that's the angles. We can use trigonometry to do that. The first one let's solve is angle Q. So look up here at angle Q. Which trigonometry function do you want to use? You can use any 3 of them you want. I'm choosing to use tangent. So I'm going to write down tangent of angle Q equals, and then put the ratio. Tangent is opposite over adjacent. What's opposite from Q? Look across the triangle. It's the side with the 65. What's adjacent to Q? It's the 33. This creates a trig equation. This equation is that the tangent of Q is equal to the fraction 65 over 33. How can we solve for Q? We want to remove the word tangent. That's called tangent inverse. So we're going to take the inverse tangent of 65 over 33. Please type that in on the calculator and push enter. This turns out to be about 63 degrees. We just figured out angle Q was 63 degrees. The only thing left to do is figure out angle R. We could use trigonometry for that, or we can use the fact that the 2 acute angles in a right triangle are going to add up to 90. So 63 plus the measure of angle R has to equal to 90. Subtract 63 from both sides, and we find out that the measure of angle R equals 27 degrees. We solved this triangle. That means we figured out all 6 parts. 3 of the parts we knew from the beginning. The side that we didn't know, we solved using the Pythagorean theorem. One of the angles that we didn't know, we solved for by using trigonometry. And the last angle that we didn't know, we solved for by subtracting from 90. So we're putting together a bunch of the recent skills that we've learned to work with right triangles.